Cryptography. For a long time, it was thought that every algorithm is breakable. I mean, surely given enough time you could break any encryption, right? Well, then came along one-time pad. And one-time pad is the only known encryption technique proven to be completely unbreakable. And this is why. So, one-time pad takes a message, and it takes a key, and the key is importantly the same length as the message. Then each letter of the key is added to the corresponding letter of the message, and you get an output. And so this output becomes the ciphertext. Now when you want to decrypt this, you just reverse the process. You take the ciphertext, and you subtract each letter of the key from each letter of the ciphertext, and you get the original message back. Now, why is this 100% secure? Well, let's say you're an attacker. What might you do? Well, you might try to guess keys. So if you guess keys, and any set of letters the same length as the ciphertext is a valid key, you might stumble across a possible key which gives you a valid English output. And so if you don't know the key in advance, it's impossible to know whether the intended message was this output from your guessed key, which is later, or whether it was hello, which was the actual output. So without knowing the key in advance, you can't guess which output is the right one, and so it's an unbreakable algorithm. But now one-time pad has a few problems which make it not practical for use. And first of all, your key needs to be the same length as your message, which is pretty easy for words like hello, but when you try to encrypt a longer message, it becomes pretty difficult to get a key the same length as the message. Secondly, the key needs to be randomized, which can be heavy on computing power. And finally, you can only use each key one time, because and hence the name, by the way, one-time pad, because you can only use each key one time. Because if someone intercepts two messages which use the same key, they can analyze those two messages to try to find the key used on both of them. So you can only use each key once. So I wrote an implementation of the one-time pad in C++. Here it is. So in my implementation, you can use any size key, because there's this bit of code which will increase the length of the key to a key long enough for the input message. So that makes it slightly more usable. Next, you can use the keys more than one time, because even if you use the same key on two messages, you can't necessarily perform analysis on it because of the way the keys are generated. So this makes one-time pad slightly more usable, and I'll show you a quick demo of that. So let's try to encrypt plain text of A with a key of S, just one letter. The output is a J. Okay, so let's decrypt that. So if we decrypt this with S, which is the original passphrase, you get, as you would expect, you get an A. But if you decrypt this message with a passphrase of, let's say, K, well, then you get an output of Q. So you can see how this might extend to messages of a longer length. So also, you can use a key much shorter in the message. So for example, let's use a key significantly shorter than this message. Let's say use a key of hi, which is just two letters, HI. and you get this as the output. So it still works even though the key wasn't the same length as the message. And of course you can decrypt it with the same key, HI. So now this does make the one-time pad more usable, but we still can't use it for communication. Now, why is that, you might ask? Well, the one-time pad is a symmetric key algorithm. So what it means to be a symmetric key algorithm is that you use the same key to encrypt as you use to decrypt. So for example, here we used high to encrypt this message, and we had to use high to decrypt the message again. So what's the problem with this? Well, let's say I want to transmit a message to someone else. Well, then we both need to know the key in advance. But how do I transmit the key to them then? Well, either we have to meet in person so that it's completely secure, or I have to send it over the internet, which is then unsecure. I could encrypt the key, but then I would need another key to encrypt the key. And so that leads to this problem of how do we transmit the key, and we can't. So then we have to use asymmetric key algorithms, which use one key to encrypt and one key to decrypt. So then what I would do in that case is I would give someone else one key, they would encrypt the message, send it to me, and then I would use the other key, which only I know, ideally, to decrypt the message. And so that's why we have to use asymmetric key algorithms in communication over the internet. And so even though this implementation will work if you just want to encrypt files for yourself, or let's say messages for yourself, then my one-time pad is fairly practical to do that, but it cannot work for communication.